Hello out there in Zoom land. Welcome to the second of our Pennsylvania Archaeological Council Archaeology Month speaker series. My name's Ira Beckerman. I'm president of the Pennsylvania Archaeological Council, and I am more than proud to present this series of speakers that will be talking this month on Wednesday evenings at 6:30. And I would like to put a shout out to our Zoom host, Hannah Harvey, who set up these particular calls and arranged the speakers and got the bio information and is making all of this happen, even though she's sitting there behind the screen like the great wizard that she is. So tonight we have as our guest Doug Riethmuller, who is going to be talking about the identity in the Late Woodland Northeast, interpreting communities of practice from the paste composition at the Thomas Luckey and the Losey 3 sites. And Doug here is a recent graduate from SUNY Binghamton with an MA in anthropology. Previously, he got his degree from Mercyhurst University in 2015 with a Bachelor's of Science in Archaeology and Anthropology. He is currently a field director at Markowski Engineering out of Ligonier, and he's had experience now working in CRM in the Mid-Atlantic states, and I will more than assume that what he's going to be talking about tonight, he has firsthand experience down to the trowel and blade and shovel and artifact. So enjoy the show, enjoy the presentation, and without further ado, I'll turn it over to Doug.
Thank you. All right, let me get the screen sharing set up. All right, I think that should be set. So again, thank you for that introduction. As was mentioned, my name is Doug Riethmuller. I recently graduated from SUNY Binghamton in the summer, and I had originally been planning on presenting some form of this talk at the SAAs in Austin this last April. Sadly, that did not happen because of everything being shut down because of the coronavirus. So I undoubtedly missed out on some great archaeology and even maybe more tragically, some great barbecue. Please bear with me if there's any odd formatting issues. Haven't done one of these before. I figured I would start with just a brief overview of what I'll be talking about. First, I'll go through kind of the research objectives that I had going into it, then the theoretical framework in which I would examine things, introduce some of the methods, contexts, analysis, both planned and then how it went, the results, and of course discussion, conclusion, and then finish it off with some thanks. So the research objectives are kind of fourfold. Sorry, I think I put it on the wrong screen. First is to determine, oops. There you go. First is to determine if the Shenks Ferry vessels at the two sites are examples of trade or the movement of people. I decided to look at this through the paste of the vessels as opposed to temper, decoration, or formative techniques. This is the biggest objective to accomplish and necessitated the examination of the clay, as the signature of clay cannot be mimicked, but decoration or formative techniques can be. I also needed to gather a control ceramic group from the region. The relational distance is hard to determine with the pXRF. So as an extreme example, if the Shenks Ferry and the Kelso Corded vessels at the site were made from the same clay, it's hard to tell that without having something else in the region to, essentially pull those values apart. I also needed to acquire clay from the region to tie the vessels to a point in space. If the Kelso Corded and Shenks Ferry vessels were made from the same clay, I don't know that that clay is necessarily from anywhere in the study area. While it's not almost impossible, they could be both from California. So using clay from the region helps tie to a point in space. For the second objective, I wanted to go beyond the simplistic, these were made here or not made here, and attempt to answer why a potter may continue to make vessels in the way that they were taught and not just the way that others nearby are making them. There's obviously many reasons why what things are decorated from aesthetic to functional. To be somewhat obvious or overly simplistic, decorations or symbols will communicate information to the right viewer. Prime example of that today are clothing brands, as a symbol adorning a shirt means a company or rough price point only to those who are aware of that symbol. Symbols are also a way to signal belonging in a group or the acceptance of an idea. When in proximity to other groups, the importance of signaling affiliation becomes more apparent or necessary, as affiliation is not assumed. To kind of pull a modern day example, if you live in Pittsburgh, everyone assumes you're a Steelers fan. However, in Erie, where I went to school, it's more of a shared occupational setting because it sits at the border of Cleveland, Pittsburgh, and Buffalo football spheres, and such group affiliation may need to be shown. This affiliation can resolve or sometimes even instigate conflict. Finally, building off of the implications of this research goes to re-examine some of the assumptions underlying where we think past people were really located and where they may have moved or who they may have traded with. The way I sought to accomplish all this was through hypothesis testing. So the first is a null hypothesis, that there's no difference in the clay used for either type, which would be that all of the potters essentially pulled it from where it was local to them. So I had to determine the relationship between Kelso and the Shenks Ferry vessels at each site. Kelso is more commonly found in central New York, and Shenks Ferry vessels are more commonly found in central PA. I have some maps that I'll get to later. Both sites sit at the edge of archaeological culture areas at this time period. First is essentially all tested vessels. I only included sherds of singular vessels or average sherds from the same vessels together that are similar regardless of site. The second is that the different clays between the sites, but there's no distinction of clay that the vessels were made from within the site. Third, that there's no relationship at all, and this would essentially support the trade hypothesis, especially if they were unrelated to clay samples. So that would be that the Shenks Ferry vessels more than likely were made elsewhere and traded in. And then fourth, could signal a distinct preference for sources between groups or trade of vessels or both. Thomas Luckey and Losey 3 were selected for comparison because of the similarity of the pottery assemblages, similar enough time frame of occupation, and because they're in different drainages. While modern borders are artificial and tend to ignore the landscape, natural boundaries often governed or guided occupations in the past. Although two different drainages are represented, both were on the Appalachian Plateau. This comparison between the two sites presented an opportunity to address the research question about how pottery paste might provide evidence for how communities of practice created identities that influence the selection of clay. So the theories that I used to examine the data pulled from several different fields, as humans are and our activities are not necessarily easily explained. Communities of practice is a bit of a flexible definition of identity, as one can inhabit many communities of practice. Elsewhere, I've abbreviated communities of practice as COP. So if you see COP, that's what it means. While Levin Wenger selected specific communities, specific examples of different communities. Some that would be pertinent for us would be archaeology, being in a sports club, a reading group, potters, woodworkers, etc. Those would all count as different communities of practice as they're united by an activity. I'm sure most of you can think of the different communities that you inhabit. Wenger has a nice quote in, I think, 2010. Such communities are not to be thought of as synonymous with ethnicity. They're networks of knowledge that are distinct from one another. They're placeholders for groups that we cannot know the full history, the full story of. Habitus, as put forth by Bourdieu and others, plays into this as the socially reinforced activities help to perpetuate our actions. From my research, potters actively establish and reestablish their training community in the selection of raw clay, the selection of temper, the combination of raw clay and temper to form paste, method of vessel formation, and most importantly to this research, the decorative patterns applied to the vessel, as those were what determined where the vessels and sherds were assigned through the archaeological investigations. While pots are not people, we recreate the way we were trained when we perform a task. Some of the identity that may have been held or taught to a potter would therefore be able to be identified from the vessels. As such, the chain operatoire is an indication of this reinforced identity, as the choices made by the potter can be found through a careful analysis. Also has identified the limitations of their choices, clay sources being the principal limitation that I'm concerned about, as referenced in the above constraints diagram. The final step is what this identity means or does. As I touched upon earlier, signal identity reinforces social ties. Constellation of practice is essentially a broader related series of communities of practice that a potter may be signaling with designs or other pottery decorations. This could unite distant family groups that would allow one to fall back on another in times of need. All of this is very flexible, but essentially an artisan is limited by their training or experiences and the real world. Reproducing their instruction ties them into a community of practice, a community of people producing goods. This can enforce and perpetuate relationships between disparate or distantly related groups. Moving into some of the contexts, not that I need to start at the geologic history of the Earth for sites that were inhabited less than 1,000 years ago, but it's pertinent to understand why clay sourcing is possible in these areas. The last glacial maximum, as shown in the diagram, or the figure to the right, shows that greatly influenced the underlying geology of both sites. Therefore, there was a great admixture of sediments, which created a bit more unique elemental signatures than may have been found through in situ decaying of bedrock to eventually form clay, as the bedrocks would be generally more homogeneous to begin with. So especially in the area, and as demonstrated by many others, there's highly variable elemental composition of the clay outcrops, which allows for relatively fine-grained, or at least fine enough grained sourcing. So the three types that were examined, I've included a couple different distribution maps, and these are obviously updated and changed through time and through different scholars' interpretations. They're all generally dated to be co-occurring, though this is hard to do, as pottery is not as well. It was attempted to be directly dated at Thomas Luckey, but some of those dates didn't necessarily correlate with the radiocarbon dates. But they're all of roughly contemporaneous time and distinct separated areas. So the Shenks Ferry is a more central Pennsylvanian type, whereas Kelso and Oak Hill are both from New York. So I'll show a better map in a second, but Thomas Luckey and Losey 3 are about in here. I don't know if you guys can see the cursor, but they're right at the border of Pennsylvania and New York. These are some photos of two of the Shenks Ferry types that were represented. The one on the left is in size, and the one on the right is cord marked. These vessels have been described by Withoff and Farber as collared, flat-lipped, with moderate neck constrictions, egg-shaped bodies, and rounded bases. Vessel interiors are smooth, while exteriors are cord-marked except for the neck. The most diagnostic aspect of Shenks Ferry and size vessels is the horizontal bands of oblique, vertical, or horizontal lines on the neck and or collar. It's grit-tempered. The cord impressed is on the right with the same basic decorative pattern, but made with a cord-wrapped stick. I did not separate the analysis out by subtype. I just included them both as Shenks Ferry, as was done through the reporting. The next are Kelso. The overall kind of schema is relatively similar, with intersecting lines that are horizontal over diagonal. Decoratively, Kelso Corded is distinguished by cord impressed horizontal line motifs on the collar. These motifs consist of vertical, oblique, and opposed oblique or opposed filled triangles. It's a collared wear with flat lips, constricted necks, short to medium collars, and elongated to globular bodies. The bases are rounded. The exterior is cord marked but smooth before decorating, and the interior is smooth. It's also it is also grit tempered. Oak Hill is the final one that it was included, and because it is as to my knowledge, not found in Pennsylvania. It was selected largely as a control because it is definitively from New York. They are described by Lenig as collared with cord-impressed decorations on the collar that consist of vertical oblique, opposed oblique, or opposed filled triangles. They also possess globular bodies with constricted necks and short to medium collars. These collars possess interior channeling, and the lips are flat. Vessel interiors are also smooth, with the exteriors being impressed by the edge of a cord wrap paddle after smoothing the surface. So this map is, let me see if I can get the laser pointer up. Shows the both site locations. So this is Bradford County and then Tioga County and Chemung County respectively. That's Corning, New York, and Binghamton is a little bit off the screen. But the Thomas Luckey site is here in yellow, and the Losey 3 site is here also in yellow. The 4 numbered points are the 4 clay outcrops that I was able to sample. All of these are connected by river systems. So you can take the Chemung River, which would then flow into the Susquehanna, which then you can get to these two. And this one, I believe, is also even connected by an unnamed tributary. So it's all connected through waterways and related to Wallace's Indian paths. They're also very easily traversed. But that's just the general site area. So first I'll talk a little bit about Thomas Luckey. It's near Wellsburg and Lowman, New York. Both of these sites are within a mile and a half of the respective state borders. As you can see, it was radiocarbon dated to the 13th to 15th century. There were 2 likely longhouses found, a lot of features, a lot of sherds, a lot of flakes. It was identified by PAF staff, Public Archaeology Facility staff out of Binghamton in '78, and has had periodic excavations spanning over 25 years for a variety of reasons. Actually all of the artifacts that I've been dealing with came from the excavation as a field school, which was done by students from SUNY Binghamton and was accomplished with a great deal of aid from the PAF. And it is currently housed at SUNY Binghamton. Losey 3 is near Lawrenceville in Tioga County, PA. The occupation is a little bit later, from the 14th to 17th century. Larger in size, 77,000 lithics, 154 vessels, a lot of features and post molds, and it was principally excavated by Skelly and Loy and is currently housed at the State Museum in Harrisburg. So the assemblages, I just kind of have these. I did not participate in any of the field work for these other than gathering the clay. So this was principally done through the analysis of existing collections. First is, these are all from Binghamton. On the left is whenever I pulled them out of the archives, and then the Thomas Luckey ones I was able to re-clean and then photograph. All of them were transported to the New York State Museum for testing. The pXRF that was available at Binghamton was down for maintenance, and I needed to have them all done through the same device for ease of testing. So the analysis roughly followed in format: gathering the clay, processing the clay, cleaning and preparing samples, using the pXRF, and then post-processing everything. Initially, I was only going to study the Thomas Luckey site, but Nina recommended adding the Losey 3 site as it provided another unique facet of studying the past and a comparison. So I had the brilliant idea of collecting clay in the winter of 2020, which proved to be rather chilly. Clay sample 1, which I gathered from the bottom of the Susquehanna, was collected near the Bradford County Conservation District office. As I was put into contact with Dan Rhodes, who was invaluable in gathering clay as he knew of these 4 sources. Clay sample 4 over here, which was much shallower and much more enjoyable to gather, was north of Sayre. Clay sample 3 was much more south and east of French's Xylem, and then clay sample 2, which proved to, as I'll illustrate later, be the most distinct clay sample and is almost pure modeling clay. It's extremely high quality. All of the other ones are more of a, clay loam or silty clay. This one is pretty much just clay. To make the clay able to be analyzed, I dried it in an oven at 250 degrees Fahrenheit for 2 hours to remove moisture. The clay samples were homogenized and pelletized for ease of study. I used a press from the geology department, which just really compresses the clay into a usable pellet form. It was cleaned before each use to prevent contamination. The resulting pellets are about the size of a double thick Smartie. To analyze it, I used the pXRF at the New York State Museum, which is this instrument over here. Half of the runs were accomplished without a filter. The other half were accomplished with a yellow filter, which allows the device to see titanium, which is important for sourcing. I'm very grateful to the New York State Museum for letting me use their equipment as Binghamton's was down. If I can get this to play. Okay, that would have just shown the pXRF gathering data, but it's fine. Oh, there we go. So each of these peaks show the relative counts of certain elements. So this extremely high spike is iron, and then you have rubidium, strontium, and other elements. That's the device itself. And it would just run for about a minute. Looking at the curve tells you pretty much nothing because it's a very qualitative measure. However, for just glancing at it, it's nice to be able to see what the expected results are. So if you see a similar curve, that means there's generally about a similar elemental signature that you're looking at. However, it also spits out these counts that would indicate the height of it into Excel, which is where I was able to then do the upcoming scatter plots and k-means analysis, k-means cluster analysis, excuse me. So there were overall 298 data points, which consist of 2 runs per specimen, as there were 145 unique vessels represented by either singular sherds or multiple sherds that were averaged into one sample, and the 4 clay samples. I'm afraid as we go forward, nothing's terribly attractive about the results. And frankly, some of the graphs get a little bit busy, but I think they show everything rather well. Between the 2 different runs, a variety of elements were sought. They are aluminum, silicon, potassium, titanium, calcium, manganese, iron, nickel, copper, zinc, rubidium, strontium, zirconium, and magnesium. The goal of these upcoming scatter plots was threefold. First was to determine if the pottery types within each site showed similar elemental values to one another, meaning they were made from the same clay. Second would be to determine if each site's assemblage differed from the other, meaning that Thomas Luckey and Losey 3 communities use different clay sources. And third, to determine if the raw clay samples matched any or all of the vessel paste, connecting vessels to a local source. The standardized data sets of element ratios shown in the scatter plots depict a pure comparison of values. In contrast, the upcoming k-means analysis provides an evaluation of whether the range of data points cluster into groups based on similarities in the data sets. K-means test offers the option to select the number of clusters based on what you might expect to find in the data. Alternatively, you can use a statistical solution, which is the elbow, for the optimal number of clusters based on plots of the variation in the data against a range of clustering levels. So this is the first scatter plot, and it's a comparison of the aluminum to potassium ratio. As you can see on the bottom, everything that's in red is from Losey 3. The file naming structure for most things was site, pottery type, and then behind these would be the actual FS number or some other similar identifying signature. So red is Losey 3. If it's a circle, it is the Shenks Ferry. If it's a square, it's Kelso Corded. And then the hollow is aluminum, and the solid is potassium for all of them. Thomas Luckey is in the blue. And you have Shenks Ferry again as circles, Kelso Corded again represented as squares, and the Oak Hill is represented as diamonds. So building from the left, these are all single vessels or sherds representing vessels. So the Oak Hill only comes out to about here-ish, as there's not that many sherds that were able to be tested. And then clay, since there's only 4, it comes out this way. But overall, there are few values presenting outside of 3 standard deviations. Thomas Luckey has more sherds of both Kelso Corded and Shenks Ferry that are above +2. But however, the sites are relatively similar, though this scatter plot shows the largest separation between the two because of the high similarity and little deviation from the mean. There's no clear separation between Kelso Corded, Oak Hill Corded, and Shenks Ferry vessels, with minor separation between Losey 3 and Thomas Luckey sites. Clay values are like the next graph in that sample 2 is very distantly, it's actually usually completely opposite of samples 1, 3, and 4. I don't know if that's because there were just the other impurities in samples 1, 3, and 4 that I was unable to remove, or if they are, very incredibly different. This one shows the difference between the aluminum and titanium ratios, and this was accomplished using the yellow filter, whereas the previous one was from a no filter run. These scatter plots support both, support the null hypothesis, meaning that both the Thomas Luckey and Losey 3 potters made both Shenks Ferry and Kelso Corded vessels from clay collected from elementally similar quarries in the region. There's some separation of the data set by site, but not in every ratio as would be expected from differing outcrop usage. This disproves the second hypothesis. Additionally, there's little separation of the types within the sites, disproving the third and fourth hypotheses. While the null hypothesis is supported by the scatter plots, the visual and subjective nature of the results encourage further analysis and validation of these results through k-means cluster. So first, k-means clustering clusters the data based on similarity of the presented values. So in this case, similar counts per element, and is based on the number of assigned clusters. Given one cluster of my data set, everything would fit into that cluster and is therefore irrelevant. Given too many clusters, it's also irrelevant. Everything would cluster independently. There's 2 ways to figure out the clusters, as mentioned before, statistically with the elbow method, as you'll see in a minute, where the program assesses the optimal number of clusters before the distance between them starts to taper off, and selectively with known data sets in mind. So first, and while it's hard to see the individual vessel sherds, I looked at everything with 2 clusters, allowing the data to hopefully fall into everything being from one site or the other. I did not do that, which supports, again, the null hypothesis. So everything in red is from the Losey 3 site, and everything in blue is from the Thomas Luckey site. If the clay at each site, being used at each site, was distinct, then Thomas Luckey would be in one column and Losey 3 would be in the other. However, that's not the case. So this one on the left is no filter, and the one on the right is the yellow filter. So the principal difference between sample 2 and samples 1, 3, and 4 is its titanium content, because very often it only moves whenever it was examined through the yellow filter. But again, even with that, there's still a mixture of both sites within, both sites within each column. The next set is only looking at Losey 3, as it only had the 2 types that I was examining, did not have any Oak Hill. The neon green is the one hybrid vessel that was identified. It did not stand out as much as I thought it would. I was very interested to see what would happen with that one. And there's some other graphs that I did not include here because it's just limited on space and time, but it did not really do its own thing as I kind of expected. But again, this is looking at the difference between types, and the Kelso Corded, which are yellow, and the Shenks Ferry, which are green, are not evenly distributed, or they are evenly distributed, they're not separated, which means they're from similar clay. Same thing with when examined through the yellow filter runs. If one was traded in or made from drastically different clay, we would expect to see them clustering in an individual column. So I would expect to see all the Shenks Ferry here and all the Kelso Corded over here. Looking at the Thomas Luckey signatures, the yellow filter is on the right and the no filter is on the left. Yellow filter again includes titanium in the results. There's not a drastic change between the two. It echoes the same, that the Shenks Ferry and Kelso Corded do not cluster independently of one another, and the Oak Hill is rather evenly mixed, if even better mixed when examining with the titanium. When examined statistically, the best number of classes or clusters was 8. To look at the no filtered results of all of them. So this one is very busy, but blue text signifies that it's from Thomas Luckey. Red text signifies that it's from Losey 3. The yellow fill signifies that it's Kelso Corded. The light green fill signifies that it's Shenks Ferry. Purple fill is Oak Hill, and the lime green is the hybrid vessel. Clay sample 2 is separate again from all of the clays. Seems the most clay-like. There's no real separation of anything by site or type, which is good. It shows that they're pulling from similar clay quarries or outcrops, and that it does not support any trade-in of Shenks Ferry vessels. This is the same when examined with the yellow filter. The Shenks Ferry from feature 33 is a bit of an oddity and appears to cluster by itself. I was kind of unable to figure out why. There's nothing on the sherd that really supported that. It could just be an aberration, or it could be that I was unable to get a clear enough signature from it whenever I was analyzing it. Again, there's no separation between site or type within site. Even the Oak Hill is again evenly distributed, though 1, 3, and 4 clay samples are again very clustered together similarly. All this goes to show that the Shenks Ferry presence at Thomas Luckey and Losey 3 is not the result of trade, but the movement of people, and more specifically, potters. That number does not necessarily have to be high, as I'll get to in a second, but 1 or 2 people could reproduce their communities of practice easily. The questions remained: what was the nature of this movement, and why do they move to perpetuate their designs? What was hoped to be accomplished through that? As alluded to earlier, identity is often created and perpetuated in comparison to others. When multiple groups are located at a single site, these identities are more important to display at some level, and possibly more levels than normally may be required when not at the periphery. A friendly or amicable environment would more likely allow for the expression of individual heritage or traditional pottery designs as a vehicle for the reproduction of linkages to past communities or commemoration of these traditional knowledges. Doing things the way that you have done them ties you into where your people are from or who they may be related to. Continuing these traditions allows for mutual assistance in times of needs, amongst many other things. Groups moved around for a variety of reasons, and tracing or attempting to trace the movement of the people and ideas that they carried are useful tools for us in understanding the past. Our typologies are artificial and limiting, but they're wholly necessary. I'm not arguing against typologies, but periodically re-examination and careful application is necessary. Communities of practice is perhaps a better method of analyzing pottery at such heterogeneous sites, rather than assuming that the identity encapsulated in the sherds is a pure marker of ethnicity. Some of the conclusions: I proved the null hypothesis that there is no or very little distinction between both inter and intra-site. Both sites likely had fluid borders and allowed for a mixture of groups. The exact relationship of these groups is difficult to tell, if ever. Losey 3 had evidence of a palisade, Thomas Luckey did not. Both were located along major water bodies and would have been able to engage in movement and trade along them. Additionally, they could have used these water routes for acquiring clay. Clay is extremely heavy and pretty difficult to move easily. Some areas of the world, people would fire the pots near their clay quarries because it's easier to move a dried pot than it is to move just the pure raw clay. That would require a lot more research and investigations in this area. They both kind of sit at a crossroads area because, as going back to the start showing the distribution of cultures maps, a lot of them don't really show any one culture clustering there. So in a general sense, perhaps being open to all was a bit of a necessity as to not choose sides. Further work, well, I'd love to have this as the final sentence of my thesis. Obviously, more could always be done. Looking at the sherds with an LA-ICP-MS, amongst other things, would provide more of a empirical as opposed to relational difference between any of them. Looking at more sites, finding more clay outcrops and samples, pulling in other controls, or moving beyond the examination of paste, looking at the formation of vessels would be one way to try to differentiate the two and see if they're made the same way. And then finally, amongst other things, experimental archaeology and trying to reproduce the vessels and see if there was any distinction between them having produced them in a modern day. There's many people to thank. Nina and Lori are probably the highest among them, as I would not have graduated without them, but many played a very important role, and that's it. I believe I have some time for questions.
Okay, okay, here we go. All right. Open for questions here. I'm going to leave the chat room open and go ahead and put some questions out while I do a little bit of housekeeping. First of all, excuse me, let me thank Doug for providing the time and sharing his results from his thesis and from his research on this pottery. And I do want to thank you. So let's see what we have in the way of questions here. I've got one here, which is for Doug. What were the run times and sampling specifics for the pXRF, and how did you settle on cluster analysis rather than some other statistical test? And I think for the more ancient of us, you may want to actually define what pXRF stands for.
Sure. I'm going to put the parameters in the chat. I think I've just apologized for the formatting of it, but this is just pulled straight from the thesis rather than reinvent the wheel. But yeah, voltage was 15 kilovolts and current of, I guess, 28 microangstroms, I think, with a 60-second assay. There's, I forget the exact paper, but essentially the longer you run the pXRF, there's a drop-off in actual accuracy. pXRF is portable X-ray fluorescence. In layman's terms, and that's more the speed that I'm understanding it at, it bombards the sample with X-rays and then measures the energy given off, which is then indicative of a certain series of elements from the periodic table. It's non-destructive, which is why I think it has found such great adoption in archaeology. And I settled on cluster analysis rather than something else. It's been done enough in the literature that I felt comfortable doing it. And because I was looking for clusters, essentially, of communities of practice or selection of clay, which would be indicative thereof, that was, I thought that would kind of be the most effective statistical method. I hope that answers your question, Rachel.
Okay. I will hold it open for another minute or so for any additional questions before I close. So I'm going to throw one out just for grins for Doug here. What I was able to gather from the presentation is that using the methods available through X-ray fluorescence and looking at a variety of chemicals, you were not able to differentiate or actually segregate clays from one location to the next, and that there did not seem to be differentiation between the clays enough to say one has a different signature than another. Am I reading that correctly?
The 4 of them were not separate. The clay sample number 2 was distinct enough in most of them. It just relied upon titanium as the largest difference, which is why it would show up more when analyzed with the yellow filter. So I would, in an ideal world, it would have been every single one of them would have been very distinct. However, that's not the hand I was dealt. And that's why I think trying to find more clay samples would be better, to actually be able to say with a higher degree of certainty, these vessels were potentially made from an outcrop here as opposed to here. But I was very, very happy to see that the clay samples as a whole matched with the vessels as a whole, in general.
Okay. If you were to have free reign on future testing, is there any additional kinds of analyses that you might propose to differentiate the sources?
Some of that would be X-ray diffraction is very useful for identifying clays. Some pre-treatments to remove any non-clay sized particles or non-clay components of the clay samples would be useful. And then also, excuse me, being able to spend more time and try to find more pure clay sources. I was limited to essentially looking in the riverbanks and other places that Dan Rhodes had been able to show me, and they're very. I'm very appreciative of that, because I checked in the Chemung south of the Thomas Luckey site and was unable to see anything, so that they weren't really using any purely local clays. But I'm just glad that it kind of worked out the way it did. I hope that answered your question. It may not have.
Sure. And there is one additional question here. And this is from Kevin McCurley. Is there any advantage or increase in accuracy in using an assay time longer than 60 seconds?
There is. Again, I don't remember the exact paper. It was either Fram either did it, or Shackley, who were two of the, I think, probably most prominent pXRF users in archaeology. And they looked at thousands of samples and were able to show just a diminishing returns curve. So, 1 second is far, far, far less effective than 10 seconds. And then, 20 is still better, but then after a while you get to, 95% accuracy, and then any additional, time moves the accuracy very marginally. If I can find that, I'll maybe try to share that. But essentially, yes, there is an increase in accuracy, but after a certain point, which is below 60 seconds, it does not really help.
So essentially, it's not linear again. It's a curvilinear.
Yep, exactly.
And plateaus off.
Mm-hmm.
Okay, I'm going to hold this open for 1 minute. Any additional questions? And barring any further questions, again, I want to thank Doug for his presentation and Hannah for hosting